This program is to test whether a given tree, that is binary tree, is a balanced tree or not. I am sure that the readers knows about what's meant by balanced tree. Balanced tree is the one in which the balance value of all the nodes will be either -1, 0 or 1. The balance is defined as the left subtree height minus right subtree height. So in order to call a tree is a balanced tree, for all the nodes, the balance value should be between -1 to +1. This program is to test that property. This program also uses the same structure node, which is having a integer and two node type of pointers left and right. The function bal is written such a way that it takes the address of the tree which we are interested to find out whether it is a balanced tree or not. If it is not a balanced tree, the function returns -1, otherwise it returns a positive number. Remember, a tree with a single node also balanced tree. The essence of this approach is as follows. This is also a recursive approach. We will be traversing the tree recursively. Whenever we encounter leaf node, it returns 1. Whenever we send 0 or null to this function bal, it returns 0. At every node, it finds the left subtree height and right subtree height. If the difference between these two things is between -1, 0 or 1, then it returns the largest height of the left and right subtrees and adds 1, it will return that one. Otherwise, that is, if the left subtree, right subtree height difference is not in between +1 to -1, then the function returns -1, indicating that that portion of the tree is not having the balance. At the same time, at every node, when left subtree height is calculated, from that side, if we receive -1, or from right side, if we receive -1, indicating that there is a imbalance in the respective sides, then the function simply returns -1 without worrying about their heights. This is the essence of this approach. Let us try to simulate how this function works. We assume that the tree as shown in the slide is used. The address of the root node is sent as an argument for this function. Thus, as it is not 0, as it is not leaf node, the statements in the else, that is L is equal to balance HR left is executed, which means that we will be traversing first left subtree of the root node. Again, we will be traversing the left subtree of the node 3. That is, now the address of the node 1 is sent as argument for the third recursive call. As that node is leaf node, it returns simply 1. Now the right subtree of the node 3 has to be traversed. Thus the statement R is equal to balance H arrow right is executed. Now we will be traversing the left subtree of the node 6. As node 4 is leaf node, it returns 1. Now the right subtree of the node 6 is to be traversed. Thus R is equal to balance H arrow right is called. As the node 7 is a leaf node, it returns 1. As the node 6 left and right subtrees are having the balance values, they are of same height 1. Thus this function returns 2 to the previous function. Now we understood that the height of the left subtree for node 3 is 1 and right subtree is 2. Node 3 is thus balanced. That is, the difference between them is only 1. Thus, the tree headed with 3, node 3 is a balanced tree. Thus, this function returns 3 to the previous function. We have finished the traversal of the left subtree of the root node, and we understood that the height of the left subtree is 3. And also the left subtree of the root node is balanced. Now we require to traverse the right subtree of the root node. Thus R is equal to bal H arrow right is called. Again with the node 10, L is equal to bal H arrow left is called. However, as root 10 doesn't have any left child, it returns 0. Now we need to traverse the right subtree of the node 10. Thus R is equal to bal H arrow right is called. Now we are supposed to traverse the left subtree of the node 14. Now as the left subtree of the node 14, that is 13, as it is a leaf node, it returns 1. Similarly, we will try to traverse the right subtree of the node 14. However, there is no right subtree for the node 14, thus the recursive function returns 0. Node 14 is having balance property, that is, its left subtree height is 1, right subtree height is 0, thus the balance value is 1, thus it is balanced. Till that point the tree is balanced. Thus this function returns 2 to the previous function call. By now we have traversed the right subtree of the node 10. We understood that its height is 2. Already we have traversed the left subtree of node 10. We understood that the left subtree height of node 10 is 0. Now the balance value 0 minus 2, that is minus 2, indicating that the tree centered at 10 is now not a balanced tree. Thus the function returns minus 1. By now we have traversed the left subtree of the root node. We found its height is 3, and we did traverse the right subtree, but however we found that the right subtree is not having the balance property. Thus the right subtree has returned minus 1. Thus the function returns minus 1. That is, if L is equal to minus 1 or R is equal to minus 1, the function returns minus 1, indicating that the tree is balanced. Thus the given tree is not a balanced tree. It is an unbalanced tree. Like this we can traverse the tree and we can find out whether tree is balanced or not.